Ambiguous grammar. Now let's see what is meant by ambiguous grammar. A grammar is said to be ambiguous grammar if there exists more than one leftmost derivation or more than one rightmost derivation or more than one parse tree for a given input string. So it is called as ambiguous. That is, it can be represented in multiple ways. If there exists more than one positive representation for a given input string, then such grammar is said to be ambiguous grammar. So, as per the definition, SCFG, G, B, T, P, S, that is non-terminal, terminal, production rules, and start symbol. This is how we define a context-free grammar. A context-free grammar is said to be ambiguous if and only if there exists string in T such that it has more than one parse tree. So if there are available of more than one parse tree, such strings is said to be a ambiguous grammar. Let's see one example. Let's consider the production rules. Rule number 1 is A map to AA. Rule number 2 is A map to A within bracket. And rule number 3 is A map to only one non-terminal character A. Now let us consider the input string is A into A of A into AA. So now let us take the leftmost derivation for this both. I am going to take the leftmost derivation. Let us start with A, and first I am going to apply the production rule 1. So A will be replaced by A. So I got AA. Now again I am going to pass the leftmost non-terminal is this A. I am going to apply production rule number 1. So I will get A. Now the first character I want is small a. I am going to replace with non-terminal character A, small a, using the production rule 3. Now I got leftmost symbol becomes a terminal character. Now this is the next leftmost non-terminal. Again I am going to replace this with production rule number 1, A. Now this first A is again replaced to be I want with A within bracket. So I am going to replace with the rule number 2. Bracket, capital A and bracket. Now I got one terminal, second terminal. Now I got this A. I am going to replace this A with small a. So A bracket, open bracket, A close bracket occurs. Now I want two A's. Now this A will be replaced by A with production rule number 3, and this A will be replaced by small a by production rule number 3. Now let us find whether we have examined our strings. A open parenthesis A close parenthesis A. Now I got my string A bracket of A close bracket A. So this is one form of representation. Now let's see how it is possible for second form, the same leftmost derivation. Again I'll start with capital A. I'm going to apply with the same production rule number 1. So I'll get capital A. Now instead of applying the production rule number 1 again, I am going to replace with production rule number 3. So directly I am having the string A. This is also a leftmost derivation. This is the first left non-terminal A. This is replaced by terminal character using the production rule number 3. Now for this second leftmost non-terminal is this A. Here I am going to apply production rule number 1. A. So A is replaced by A and A. Now this A is again replaced by production rule number 2 by open bracket, capital A, close bracket. Now this is the non-terminal character and this is the first leftmost non-terminal. I am going to replace it with A. This is again I got a terminal and here I got A. I want two A's. So I am going to replace it by production rule number 2 by A. Here I want to apply the production rule number 3. This becomes 1A. This becomes another A. Again I am going to check about this string Here A, open bracket, A, close bracket, A, A. Traverse from left to right. The lymph nodes I'll get A, I'll get both for both I'll get A, open bracket, A, close bracket, A. When you take this for this input string, I am able to represent two leftmost derivations for the string. I am having two different positive representation for the same leftmost. I can have a one leftmost and one rightmost uniquely, but it should not have repeatancy in either left mode or right mode. In simple, if a grammar is able to be expressed in a multiple pass tree, then such a grammar is said to be ambiguous grammar.